Hi everyone, welcome to this video by Data Science. So we will continue our discussion on the time complexity, and in the previous lectures we discussed what is the time complexity, what were various notations to depict time complexity. There are three methods to depict any time complexity. It is first is the best approach, the second one used to be the average approach or average time complexity, and third used to be the worst scenario, if you remember. And the worst scenario is denoted by big O. So in this video we are going to deep dive on what is big O, and we will discuss various notations that you see generally on internet, like for example there is O1, on square, log n, etc, etc, etc. So we will discuss each of those major scenarios. So there are 5 major scenarios. We will discuss each of them. We will try to understand from a layman perspective, what does it mean? Because for example, if you show this to anyone who does not know computer science, he will get confused. So we will try to understand first of all from a layman perspective, then we will explore few of the examples that how do they look like. Okay, now if you don't know programming much right now, that is fine. Just try to understand the concept that I'm trying to explain, because once this time complexity topic gets over, we will start solving Python programming questions through algorithms, through various strategies. So then you will understand the Python coding. But right now just try to focus on what I'm trying to say, what is the meaning of time complexity. Okay, so now let's move forward with the discussion here. So for example, let us say we have a list. Now we have discussed this example earlier as well, but let's say let's discuss it once again. Let's say there is a list and it has elements, for example 3, 5, 7, 9, 12, and you are given a question. Write a Python code to determine if an even number exists or not. So for example, write a Python program to check if this list contains an even number or not. Okay, so let's say this is the question. Now without coding, how will we actually go about solving this? Let's forget about coding right now. So our step will be that we will first of all start searching elements from the start. Okay, we'll go from here to we'll check the first element. Is it an even number? If it is no, then we will move to the next one. If it is yes, we will mark ourselves yes. So for example, let us say these are the elements 3, 5, 7, 9, 12. Okay, so first of all, we'll first of all go to 3. Now this will result in no, this is not an even number. So what will happen? I will move to the next number. Now, is 5 an even number? No, 5 is also not an even number. So now I'll move again to next 7. Is 7 an even number? It is not an even number. After that I'll move to 9. 9 is also not an even number, and then I will move to 12. And this means it is an even number, and yes, I will return. So to determine whether this list consisted an even number or not, in the worst scenario, so now there could be scenario that this 12 number was present here, correct? But if you remember, big O means the worst time complexity. So to exactly tell whether this list contains an even number or not, you will have to propagate through all of the elements one by one till the end. Because if you have not completed the list, if you have not evaluated all the numbers, you cannot for sure shot say that that list contains an even number or not. And this is what depicts big O, or time complexity. And this depicts, for example, this is generally called On. That because as the size of your data set increases, right now there are 5 elements. What if there were 10 elements? What if there were 15 elements? So this things keep on varying. Now depending upon the size of your data set, your time to execute this particular code will vary, right? So the number of operations that are present to execute any code is dependent upon the size here. Okay, so this is what time complexity is. The time complexity, as we discussed in the previous video, is the rate of change of operations to execute a code depending upon the size of the data set. Okay, so let me define it once again. We have already discussed this, but just I'm giving a revision. So time complexity is generally the rate of change of operations, rate of change of operations with respect to the data size, with respect to data size. Now, why is this important? Because as I mentioned earlier as well, when you're working in a company, initially you might for example, to do a POC, that is proof of concept, you might be working on a data of 1000 rows. Now, let's say you created an algorithm to solve a particular scenario. It worked pretty well here. But in reality, you'll be working on millions of rows. Okay, and you don't know what if the number of operations for a million rows, it can stay, for example, it can be grow linearly, it can grow quadratically, it can grow exponentially, whatever, it can be any growth. Okay, and that is what there are different scenarios, and these scenarios are called the different type of big O notations. So your how your time complexity or number of operations vary with the input data set. Okay, so there are multiple scenarios to this, and they are called big O's. So we will discuss each of them separately. In this video, I'm going to talk about the constant time space. Constant time space, or you can say O1. O1. So what does it O1 mean? We will discuss in few seconds from now. But I hope this explanation is clear so far, that time complexity is the rate of change of operations with respect to data. Now this rate, there are multiple scenarios to see this rate, and that is what we are going to explore through the next 2 or 3 videos. What are various those scenarios, and how does my time complexity varies? So now let's discuss the first time complexity, that is O1. O1, so O is the part of big O, it means, right? So that we say big O, 1. So 1 means constant. This denotion means it's a constant time space complexity. What does it mean? It means that my code, whatever code that I have written, the execution of that code does not depend upon the size of data set. Okay, the execution of that code, or for example, number of observations that I'm having in that code, does not depend upon the size of the data. Now let's try to visualize through this couple of first of all, couple of real-time examples. Let us say you are having so let's do one thing. You have your phone with, while watching this video, open your phone, have it in your hands. Okay, so let's say this is your phone. Now your phone will have, time to time, what happens, you keep on adding contact of people, for example, right? So right now, for example, let us say you have 1000 contacts in your phone, and tomorrow, maybe 2 months down the line, you might have 1200. 4 months down the line, you might have 1800 contacts, or you might have 2000. So your number of contact in your phone of your people is increasing. Now let us say your objective is to find the phone number of a person, let us say Durgesh Mehta. Okay, and there is only one Durgesh Mehta, there is no duplicate, for example, let us say. So let us say you have to find this person in your phone book. Okay, so let us say this is your phone book. Yeah, there's a search bar where you, for example, search the person's name, and here you have below this you have all the 1 2 3 4 5 6, like just like in your phone, all the contact list. Now if you have to search for this person Durgesh Mehta, tell me one thing. First of all, ask yourself, do I need to check the whole data, the whole list, to get the number of Durgesh Mehta? So one method is that I scroll from right from the top and I go till the bottom, and I look for it, that do I see Durgesh Mehta. It involves like a lot of time, correct? So we don't do that. What we do, we simply go to the search bar, we just write down Durgesh Mehta, and what will happen, it will give me the result. So what has happened here, have I searched all the elements in the list? So searched all elements, tell me this. No, I have not searched everything, correct? I just know the name of this particular person, and I just filtered him directly. So this is what constant time space means. Now does not matter your phone has 1000 contacts, 1200 contacts, 1800, 2000, or maybe 2 lakh contact. The number of execution, the time required to search this particular part will remain same. It will not be dependent upon the number of contacts which are present in your list. And this is what is the meaning of a constant time space, that whatever your code is, it is independent of the size of the data. As the data size grows, the number of observations in your code do not change. I hope this is clear. Now let me explain one more example. Let me explain this through one more example. So let us say you are present in a library and your job is to, so let us say there's a big library and it has shelves. So now this particular shelf is of this size right now. Okay, and it has let's say 500 books. Now what happens over the time, this shelves keep on adding we keep on adding books to this shelf over the time. For example, every month for example 10 books keep on adding, 10 every month keeps on adding. And let us say you are standing here, and your job is to just select the first book which is present here. Okay, this is the first book. You always want to pick the first book here. Now to pick this first book, do you need to scan all the data, scan whole data set? No, right? Because you always want to pick this one. Does not matter if this keep on increasing. Let's say today is 500, tomorrow there might be 5000 books. It does not matter because you are searching, you're only picking the first book. So what happened in the first example, we searched someone by name. Okay, by name we searched, and we did not need to scroll through whole data set. Here we searched something by the position of the book. Correct? The position of book was that I'm always picking the first book. So these kind of scenarios, when you search something by name, position, or some other parameter directly, all this depicts constant time space. So I'm just trying to explain you visually that what does it in real time mean. We will work through a code as well to understand this, but I hope these two explanations are clear in your mind, that what does a constant time space means. So irrespective of the data size, the number of operations that you are going to do to achieve the result does not change. Okay, now let's move to our notebook. Let's try to solve it a couple of cases to understand what is the meaning of constant space. Now let us say you are having a list. So let's say my underscore list, this is equal to 10, 20, 30, 40, 50. Now let's say your task is to, so the question that is given to you, question is, so return me the, let's say, second element in the list. So how will you do this particular question? It's pretty simple. You will do my underscore list, then you will go, so 0, 1, so you'll type 1. Okay, and now when you print it, you will get the second. Now let's say right now there are 5 elements. What if there is 60, there is 70, there is 80? The size of data set keeps on increasing. This does not has any impact on the result, the number of operations, because this is, remember in the previous lecture we discussed what do you mean by operation. Operation means any list assignment, any variable assignment, any or anything that you do, that is an operation. Now this is that particular operation where you have created a pointer here and you are just returning this particular value. So it does not matter with the size of your data set, and this means constant time space. Okay, so return me the second element in the list. Now let's try to solve one more question for this particular scenario. So let us say we have a dictionary. So let's say there's a dictionary is equal to it has a key, for example name. Okay, so let's say the name is Rahul, and contact, so let's say so 9915, let's say this is contact. Okay, let's say then we have email. So email, you can write down rahul.singh@gmail.com, for example. Let's say these three are the elements present in there. So right now you have these three features about this particular person. Now your objective is to filter to get me the name of the person in this list. So let us say this is the so yeah, I need to just pass it as like this. Okay, so let's say this is first dictionary. Okay, so now what I need to do is, for example, I need to, my question here is, so let's start. What is the question? Question says that return given the user details, tell me his or her, for example, contact number. Let's say this is the case, contact number. So what are you going to do for this? You're simply going to do dict. Okay, and you're going to write down the key. This is key value, so you will write down contact. Okay, and this is the operation, and you will get the number. Now does not matter if dictionary contain, right now it contains 3 key value pair, 1, 2, 3. Now what if this dictionary contains 5,000? Does not matter, the contact will remain same. Okay, and you are doing just one operation to fetch this result. So to answer this question, so this particular question can be answered using constant time space or constant time complexity. So this is the meaning of I will say constant time complexity. Now let's go to the PDF. There is another example for constant. For example, let's say you have simple arithmetic operation. Let's say you are adding two numbers, a is equal to 5, b is equal to 10, and you're returning a plus b. Now when you're printing result, it does not matter what is the value of a, b. For example, you can simply do a plus b plus ab plus a into 2 plus b into 3. For example, you can do anything here. This all is one operation only. Okay, and this does not depend upon what is the value of a, what is the value of b. Okay, for example, let's say there can be other variables as well, c is equal to 50, but we are not determining that, right? We just using a and b and we are printing the result. Or even if we use c, this is just one operation and this is not dependent upon the size. Does not matter how many variables you include, the size, the number of operation will remain one here in this simple arithmetic operation, and that's what it is, the meaning of constant time space. Now, for example, checking a single condition. Let us say you are given a number, you want to check if a particular number is even or not. So what will you be doing that? For example, so let's look at this question only. Let's say this number is 8 and you want to check if this particular number is even. So you'll put this condition, if number remainder 2 is equal to 0, then print even. Otherwise, do not do anything. Now, does not matter if this number keeps on changing very high, right? So for example, let's say this num is equal to 1000. Okay, now if num remainder 2 is equal to 0, print f the given number num is even. Okay, and so this is your scenario, and you will do else, and you will simply print the is odd. For example, you simply do this. Now does not matter whatever number, how high big number you put here. Okay, you're simply running these two operations, and these two operations are independent of the size of the number. So this is what is the meaning of constant time space. I hope I was able to explain it clearly. If you still have any doubt on this particular, you can comment below. In the next video, we will be discussing about the linear time space, and we will discuss all the possible. There are 5 scenarios of time complexity and big O. We will discuss each of them one by one. So this was the constant time space, where your execution time or number of operations to execute a code is independent upon the size of your data set. So thanks for watching this video. I'll see you in the next video.